The angle addition postulate is similar to the segment addition postulate in that it allows you to add angles together. Let's take a look at with this diagram. The angle addition postulate says that if ray BD lies in the interior of angle ABC, then something must be true. What is that? Well, here's ray BD, and it is indeed inside or interior of angle ABC, and it splits angle ABC into two parts. This part, angle ABD, and if we take a look at the measure of angle ABD, and we join it or add it together with the measure of this second part, angle DBC, if we add them together, what's the result? Well, this is a postulate, remember, so it doesn't take a whole lot of thinking to see that it's going to be the same thing as the full angle all the way ABC. So those two individual pieces give us back our full angle ABC. Now let's take a look at an example. Let's suppose that angle 1 in this example measured 25 degrees. And angle 2 measured, looks bigger, so let's call it 32 degrees. What can we conclude about the full angle here? Well, that angle's name would be FEH. What can we say about the measure of angle FEH? According to the angle addition postulate, it would just be add those two smaller pieces together and they make that full angle. So it's going to be 25 degrees plus 32 degrees for a total of 57 degrees for angle FEH. Now let me take a look with you at another example of how the angle addition postulate can be used, and it's a little bit different. This time, let's say that we know the measure of angle FEH. So we know the whole thing, and let's say that it's 63 degrees for this example. And we also might know one of the parts of it. Let's say we know angle 2 measures 30 degrees. Can we find the measure of angle 1? Well, of course we can. All we need to see is that the whole thing is 63, and if we take out this part, if we take out this 30-degree portion of it, what remains is angle 1. So that would be how we could find angle 1. And in this case then, angle 1's measure would be a total of 20, nope, that's not it. Let me do my math right. Angle 1 would just measure 33 degrees. All right, so in example 2, we see a diagram with several rays coming out from the same vertex. And there's some markings that tell us that these two angles, angle JOK and angle MOL, are congruent. In fact, let's just tick mark that to show that we've noticed that. Those two angles are congruent. They match. In the description, it says that angle JOL is 85 degrees. Now, angle JOL comes out all the way across to here. So this entire angle is 85 degrees. We also are told that angle LOK's angle LOK here in the middle, that portion's 37 degrees. And then we're asked to find an angle, and the angle they want us to find is angle LOM. LOM would be here. So this is our question. How big is angle LOM? How can we figure this out? Well, let's start out by using the fact that we have this entire angle is 85 degrees and we know a piece of it. So if we use this angle addition postulate, we should be able to figure out this second piece to it right here. In other words, angle JOK. Angle JOK would be found by taking and adding that 37-degree portion, and if we do that, then we get the full rotation from JO to L, and that's our 85 degrees. So that's a total of 85 degrees. If we simply subtract out the 37, then we have the measure of angle JOK, a total of 48 degrees. But our question was angle LOM. What's angle LOM? Well, angle LOM, remember, is congruent to angle JOK. So this is also the measure of angle LOM. 48 degrees just again. Now, in example 3, our picture kind of got messy, so we'll probably want to redraw that. Let me just get another sketch of it. You want to redraw it in your notes too. All right, we're ready to go with a new setup. So angle JOK in this case, we're going to want to add these to the picture again. Angle JOK is our 50-degree angle. And let's go ahead and put that as MOL as well while we're here. Our congruent angle is 50 degrees as well. We're also given that angle LOK is 32. Angle LOK is 32. And we're asked to find angle JOM. So we want to come along this angle here, JOM, or this entire rotation. I'm going to use the angle addition postulate and just add those together. So my three angle pieces are 50, 32, and 50 again. All added together makes angle JOM. And that gives me a grand total of 132 degrees. And our last example. Looks like I need another picture. Let me recopy that. You'll want to do the same in your notes. For our last example, we see some algebra expressions. So let's go ahead and write those in as well. We're first told angle JOK is 3x plus 1. I'm going to do the same thing I did in the last example, and I'm going to write the same 3x plus 1 on my second angle that's congruent. We're also given angle JOM. Angle JOM, that's the biggest angle in the picture. That's all the way around, as far as we can go in this diagram, is 110. And finally, we're told that angle LOK, our middle angle, LOK, is x plus 10. So this one's going to be similar to number 3. We're going to just say that if we add all three of the individual pieces, our grand total is the 110 total. So our three pieces are 3x plus 1. I want to add that to x plus 10, the second piece. And finally, add that 3x plus 1. And make it equal our total all the way around is 110. Now working on the algebra here, our like terms, 3x, x, and 3x makes a total of 7x. And in the numbers we have 1, 10, and 1 all added together gives me 12. For a final 110 on the other side, just bringing that down. Let's subtract that 12 off. Both sides, cancel them. And now we're left with 7x and a total over here of 98. Reducing that 7x down to 1x by divide by 7 gives us a final x value of 14. So x is 14, and now that's our question. Yay, we're done. X is 14. We could plug that in and check, but for the sake of time, I'm going to move on. All right, so moving on, we have a new vocabulary word. It's angle bisector. And an angle bisector is pretty similar to a segment bisector. You get the same idea. The word or the prefix bi means two again, so we're going to cut. Remember, sector means to cut, or sect means to cut, so we're going to cut it in half into two equal parts. In a diagram that would look like this. If we had an angle, we would need to see another ray coming through that angle, and it needs to come from the vertex through the interior of the angle and such a way that it cuts that angle into two equal parts. So you would end up with congruent angles. And if that's the case, then you have an angle bisector. In example 5, we have one of those. It tells us in the directions that that ray IQ here, ray IQ is an angle bisector. So that means again that these two individual angles it's made are congruent. What two angles are those? Well, we need to name them. So we're going to name the first one angle NIQ. Notice I'm putting the vertex in the middle. Angle NIQ. And it's congruent to our second angle, angle QIP. So in number 6, they give us some measures. If we know that angle NIQ is 42, I'll add that to my picture. What can we say about angle NIP, the measure of angle NIP? NIP, notice, is the whole thing, all the way around, made up of two 42-degree angles. So to find its measure, we would just simply double 42. 2 times 42 gives us an answer of 84 degrees. And then our final example. Let me get a new copy of this picture. You'll want to do the same thing. Okay, here we go. So let's put our labels in. First, angle PIQ. Angle PIQ. PIQ is here, and they tell us it's x plus 26. NIQ, here and congruent to it, tick mark that, is 3x. And we're asked to find angle NIP, the whole angle. Well, how are we going to do that if we don't even know what x is? We're going to have to use the relationship. That relationship that the two angles were congruent. So if they're congruent, that means they have the same measure. In other words, my 3x is equal to my x plus 26. All right, some algebra. Here we go. Solving for the x. Let's bring that x off of the right side, subtract it off, and make that 2x and 26. 2x is equal to 26. Then we'll reduce the 2x's down to 1x by dividing by 2. And our 1x is now 13. So we have to find NIP still, but now that we know what x is, we know the individual measures by substitution. 3 times 13 is 39. And our second angle was x plus 26. In other words, it's 13 plus 26, which is also 39. That tells me I did my algebra right. So what does that mean for the entire angle? The whole angle NIP? I'm just going to be adding 39 and 39, or taking 39 times 2. Grand total would be 78 degrees. And that's how you do the angle addition postulate.